The next type of mean that we're going to look at is finding the mean when the data that you're given has already been grouped into bins or buckets for you. So this data here corresponds to the first example we had, where we had sampled 30 males from the city of London, and we had bucketed or binned all of the adult males into these categories here. Okay. So what is the mean when we don't actually know the exact heights of the 5 people that belong in this bin of being between 165 and 170 centimeters? 7 people that are in between 170 and 175, but we don't know their exact height. Is there a way for us to come up with a sensible estimate for the mean of the 30 males that we had sampled? In order to do this, we're first gonna rearrange this table and add a couple of columns as such. So in this table here, I have added an extra column, which I call the midpoint of my bin. So the midpoint of my bin that ranges from 160 to 165 is 162.5. 167.5 for the bin that ranges from 165 to 170. And do the same thing for each of the bins that we have. The frequencies, which we denote by Fi, so F1 is 0, F2 is 5. I should have mentioned the midpoint X1 is 162, X2 is 167. Okay. And I've added another column here that is the product of the midpoint or my X's and the frequencies, my F's. Okay. And the estimate for the sample mean is given by this formula here. Okay. So let's apply the formula first and try to make sense out of what it's really telling us. What we want to do is we want to sum up all the values in this fourth column here. So I ranges from, how many bins do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8 bins. Okay. Divided by the sum of all the frequencies. Okay. And the sum of all the frequencies is a sum of this column here. Obviously, I ranges from 1 to 8. So if I add these up, so if I add all the frequencies up, okay, let's rewrite that sigma. Obviously, there were 30 males that were sampled. And if I add up all the products of the frequencies by their midpoint of the heights, that ends up equaling 5,315. So using these two sums, I'm going to compute my mean here. It'll be 5,315 divided by a total of 30 males. And if I make that calculation, I get 177.17 centimeters. Okay. Now if we go back to the exact mean that we had calculated in our first video in this section, the mean in that section was 177.07. So as you can see, the mean that we had estimated, in spite of not knowing the exact height of all 30 males that we had sampled, gets us a pretty close value to what the true sample mean was. Okay, we're off by 1 decimal point. So if you take a closer look at the formula here, what we're really doing is, let's take a look at this second bin here. Okay. We don't know what the exact heights of these 5 people are. However, what we're doing here essentially is we're letting all 5 of these people have a height of 167.5. In this particular bin, we're letting all 7 people have a height of 172.5. So what we're doing here is, you can think of it as being a simple mean, in that we add 167.5 plus 167.5 plus 167.5 5 times. Therefore, 5 times 167.5. Do the same thing for 172.5. We assume that there's 7 people that have a height of 172.5. So add that 7 times to get 1207.5, or 7 times 172.5. Do the same thing for each of the bins, and we are left with this part, or the numerator. Okay. And the denominator obviously is the size of your sample size. If you add up all the frequencies, obviously, okay, you're going to get the 30 males that you had initially sampled. Okay. So there you have it. If you have data that has already been grouped for you, hope is not lost. You can still estimate a pretty sensible mean for this group data set. The next question that I would like to do is, what if we wanted to calculate the median? Okay. So the median, we all know, is going to be the middle point of our data. The reason why I've added the cumulative frequency here is because we have 30 data points. Okay, we're going to have two middle points, right? We're going to have x15 and x16, and their average will make up my median. Now again, the problem is we don't know what the exact height of the 15th person is, and we don't know what the exact height of the 16th tallest person is in our data set. But just like we had done for this grouped mean, okay, what we can do is we can estimate what the height of the 15th tallest and the 16th tallest person is. Okay. The 15th person, the 15th and 16th tallest person falls in this bucket here. Okay. So we assume that their heights are 177.5 and 177.5. Take the average of 177.5 plus 177.5, and we are left with 177.5 as our median. And in fact, the median that we had calculated in the first video happened to be exactly 176.5. So again, in spite of the fact that we don't know exactly what the height of the 15th and the 16th tallest person was in our sample, by letting their heights be an average of, or the midpoint of the bin that they belong to, okay, we can estimate the median, or the true median, of the 30 males by using this particular method here. And as you can see, just like the mean, it does a pretty good job in estimating the true median.